Okay, so let's now do subnetting and cider. So I'll typically give you problems either in the class C or class B address space. So let's do one example for each of them. So let's say we have 5 units in an organization A, B, C, D, E, and each of them need computers unique IP addresses for these many hosts. Okay, so 10 hosts, 15 hosts, 20, 25, 30 hosts. Okay. So I didn't give you an address space. Okay, so it's your task to find which address space you need and just choose any suitable address space. Okay, so let's do the math for this first. So we have here, right? So uh, you have division A 10 cores. So 10 cores you can have, you need 4 bits to represent 10 cores uniquely, right? Because 2 to the 4 minus 2 is 16 minus 2, 14. And 2 to the 3 minus 2 is just 6. So you need 4 bits. Now for division B you have 15, so that's 5 bits because 2 to the 4 minus 2 is 14. And then for C you have 20, that's again 5 bits. You can go up to 30 cores, right? So it's all 5 bits. Okay, so you need, you take the maximum among this, which is 5 bits, right? So now you have 5 subnets to take into consideration. So you need 3 bits to represent just a subnet part. So we can use 0, 0, 0 for this subnet, 0, 0, 1 for this, 0, 1, 0 for this, 0, 1, 1 for this, and 1, 0, 0 for this. So we need 3 bits for subnet part. And 5 bits for the host part. So we need a total of 8 bits, right? And this fits within a class C address space because a class C address space has 8 bits for the host part. So remember, in subnetting we can exploit only the host part. We cannot touch the network part. Okay? So we have 8 bits in the class C address space and we can accommodate all our 8 bits that are needed, right? So this is where you need to now choose a proper class C address space. You could choose anything you want, like 202.45.80.0. This is a class C address space where you have 8 bits for the host part. So that's what I have chosen, 202.45.80. Okay, so it's up to you to choose anything. Okay, so you could choose something like 199.34.20.0. That's good enough. Okay, you can work with it. All right. So now once you fix the class C address space, so you have this is 202.45.80. So now you have 8 bits for the host part. I'm going to fix the first 3 bits to be corresponding to the subnet part and the last 5 bits for the host part. So this is how they come out to be. Okay. So now your first task is to find a subnet mask. Remember, subnet mask is a sequence of ones followed by zeros. So how many ones we have? The number of ones corresponds to the network part plus subnet part, and the number of hosts corresponds to the host part. So you have 24 bits here and 3 more bits here. So 24 plus 3, 27 bits represent the network plus subnet. So you have 27 ones followed by the 5 bits for the host part, so 5 zeros. So that in binary comes out to be 255 for the first 8 bits, another 255, and another 255, 255. So 24 ones. Then you have 3 ones followed by 5 zeros. So that corresponds to 3 ones followed by 5 zeros is this. So you have 128, 64, 32. So 128 plus 64 plus 32, that is 224. So it is 255, 255, 255 dot 224. So now let's work on the subnet addresses. So the subnet address means all these bits in the host part should be 0, right? So if all these 5 bits are 0 for class A, it will be these 3 zeros plus again 5 zeros, so all 8 zeros. So 202.45.80.0 slash this 27 to indicate the subnet mask. Okay. Now the broadcast address means all these 5 bits are ones. So if all these 5 bits are ones, that will indicate something like this. So if all these 5 bits are ones, it will be 202.45.80.0000111, right? So that is 31. Okay. So that's why we say the sub broadcast address is going to be 202.45.80.31/27. Okay, so the range is going to be 202.45.80. You have 3 zeros followed by, you can have all the way up to 1. Okay, and then you can go and so on up to 202.45.80.000111110. So that is 30. Okay, so the range is going to be simply 1.1/27 202.45.80.30/27. Okay. So for this division, you have 001. So if you want to find a subnet address for B, division B, you have 202.45.80.001, then followed by 5 zeros. So that's going to be 32. This is 202.55.80.32/27. Okay, so that's a subnet address. Now for broadcast address, 202.45.80.001 followed by 5 ones. So 202.45.80 dot. This is 63/27, and the range is going to be 202.45.80.001. Then you can go something like this all the way to 202.45.80.0011110, right? So that corresponds to this is 32, 33/27. And this is 32, 62/27. Okay? You can keep doing like that for class C. Now you see a trend is being followed. So if you go in this order, this is 0, right? In binary decimal, 3 bits. Then this is 1, this is 2, this is 3, this is 4. So if you go sequentially like this, things become sequential again with IP addressing. So this is 80.0/27, and that's a broadcast address. Everything in between is a valid unicast IP address. Then you go from 32 to 63. Okay, that's again the subnet address and the broadcast address, and everything in between is a valid unicast IP address. Similarly, from 64 to 95, then everything between 65 to 94 is a valid unicast IP address. Okay. That's what you do. All right. So now let's do the other one.